Okay, so remember now with the cubic graph, when you want to sketch it, you need the x-intercepts, you need the y-intercept, and you need the stationary points, the turning points. That's the most important. And then the point of inflection. Sometimes they ask that. Okay? So you can already see the y-intercept is plus 3. That's the easiest one. The constant is your y-intercept. The challenge is normally to find the x-intercepts. That can take some time. So what you do to find your x-intercepts, like always, for x-intercepts, you put y equal to 0. So we're going to say 0 equal to x to the power 3 minus 3x squared minus x plus 3. Just put it equal to 0 and then solve x. Okay? Then we can use the factor theorem and check. What happens when I substitute 1? Will I get 0? Okay? 1 to the power 3 is 1. 1 to the power 2 is 1. So 1 minus 3. And then here, minus 1 plus 3 will give you 0. So when you substitute 1, the output value will be 0. F of 1 is 0. Okay? F1, 1 to the power 3 minus 3, 1 squared, minus 1 plus 3 gives you 0. So when I put 1 in, I get 0 out, which means x minus 1 is a factor. X minus 1 is a factor. Okay. So that's a good way to start. If 1 doesn't work, and it doesn't give you 0, then you try negative 1. If that doesn't work, then you try 2. Then you try negative 2. Let's say 3 worked. Then you know x minus 3 is a factor. Okay. So x minus 1 works. So we can say x minus 1, and then x, think about it, x times x squared gives you x to the power 3. Plus 3, this is negative 1, so the last one must be negative 3. Okay, so now we have to check the middle term when we factorize. We already know x minus 1 is a factor. Okay, x times x squared is x to the power 3. Negative 1 times negative 3 gives you plus 3. Now you can use that method where you can say, how do I get to negative 3x squared in the middle? Okay, negative 3x squared must be equal to that one times that one, and this one times this one. Okay, because this is going to be some kind of an x. So let's call it bx times x, and then this one is negative 1 times x squared. So when you multiply this, you get negative 1x squared. When you multiply those two, we call it bx because we're not sure yet. Bx times that x gives you bx squared minus x squared. And then if you take it over, the minus x squared, it's negative 3x squared. Take it over, it becomes plus x squared will be equal to bx squared. So negative 3 plus 1 is negative 2. Therefore, we know that b will be equal to negative 2. So we know this part must be negative 2x. Okay, so remember this method to find the middle term. And now we can factorize it. Now we can say it's going to be x minus 3x plus 1, the other two brackets. Okay, so when you factorize this now, you get x minus 1, x plus 1, x minus 3. Okay. Okay, x plus 1 times negative 3 is negative 3, plus 1x minus 3 gives you negative 2x. And therefore, when you put this equal to 0, if you go back here, we put it equal to 0. So when you put this now equal to 0, you can say, therefore, x will be equal to 1, or x will be equal to negative 1, or x will be equal to 3. There's my 3x intercepts. So I found my 3x intercepts. Okay, that's the first step, is to find your x-intercepts. There we can see it. Okay, the last part, finding the x-intercepts. Okay. Okay, so we looked at how to find the x-intercepts. Now we're going to look at how to find the stationary points. That's the second important thing for the cubic function, is the turning points. The stationary points are your turning points, the minimum and maximum. So for that, we need to put the derivative equal to 0. So the derivative would be negative, it will be 3x squared minus 6x minus 1. Put it equal to 0. And then you find your x values for the stationary points, the turning points What are the x values? So if you look at this one, you will see you can't factorize it, okay? Because it ends with a -1, so -6. So you're going to have to use the quadratic formula. That can happen. It can happen that you actually have to use the quadratic equation x equal to -b 6 plus minus the square root of b squared minus 4a times c, the whole thing over 2a. And then you have to just solve it like that. At least we know how to use the quadratic formula. So if you use the calculator and you check, you're going to get these two x values. They are the x value for the turning point. Okay? We have to put them into the original equation, not into this one. Some learners put it in here. You have to put it into the original to find the y values for the turning point. So when you substitute f -0,15 -0,15 to the power 3 minus 3 -0,15 squared, and then minus, and then -0,15 plus 3. You can solve that and see what is the y value for the turning point. Okay. Okay, so there you can see we substituted -0,15 everywhere, then we substituted 2,15 everywhere into the original. Then we get the y values for the turning point, the maximum and the minimum turning points. We got our turning points, we got our y-intercept, we got our x-intercept, so now we can sketch it. Okay, so let's look at what the sketch will look like. Right, so there's the graph. Okay, turning point, -0,15, just after 0, just a little bit this way, -0,15 and 3,08, just above 3. Why is it a little bit above 3? Because the y-intercept is at 3. It's a little bit higher. And then it starts going down. Then you get your x-intercept at 1, another x-intercept at 3, and another x-intercept at -1. Turning point. As you can see, the turning point is not exactly in the middle between -1 and 1. Okay, it's not exactly in the middle, like with the parabola. Remember with the parabola, the turning point is exactly in the middle between -1 and 1. In the middle, but here it's not. There's 1, there's 3. The turning point is at 2,15. It's not exactly in the middle between 1 and 3. Okay, so there's everything you need.